Hello everyone, my name is Chaitanya and welcome to this video where I will be explaining how objects and global variables are defined in SWMM5 engine source code. So let's get back to where we left in the previous video. So in previous video, this main file over here is compiling a command line executable which will run a simulation and requires three inputs: input file, RPT file, and binary file. In this video, what we will be learning is we will be learning about object file, which is inside the SWM5 project. In SWM5 project, you need to expand the headers file, and in headers file, you will have this object. In this object.h file, you will have various objects defined, uh, and the other one which we will be looking at is globals.h. Okay, so this is another header file wherein the authors have defined a couple of variables which are global variables. So global variables are variables which can be accessed from any part of the program. So the issue is uh, C files are compiled into a separate object when we compile them. So I'll show you why we need global variables, because when we compile this particular project, so let's open the file. So yeah, if I go to this particular folder and if I delete all the object files, mm, okay, I'll delete this one as well. And if I recompile this project, okay, you would see for every C file in the source folder, it will create a .obj file. So a obj file is one compilation unit, and once you compile a C file into a obj file, there is something called as linker inside a compiler. What linker does is it links all these obj files and creates a one single target file. So in this case, our target file is a DLL file instead of a executable file, which is stored over here. Again, if I go over here, um, so in build folder, we have debug, yeah, over here. So this is our target file. So when we run this particular application, uh, will access, I will delete the DLL. So if I rebuild the project, you could see it will create the DLL files. So this is our target location. So before it creates the DLL file, what the compiler does is it creates these OBJ files and then it creates the DLL file. Back to global variables. So each compilation unit, so if a variable is defined inside the datetime.obj, let's use this obj file as an example. So if you have a variable defined inside this particular translation or compilation unit, you cannot access it in the other compilation unit. So for that reason, we need global variables so that we can access them throughout the application. So this is about global variables. We will look into more detail about global variables, but before that, we will look into objects. Okay, let's. So these are objects. Okay, and this is stored inside header files folder. And in this folder, you would see objects.h. So what this file basically has is, when you open SWMM, and just a second, let me check which IMP file we are using for this particular project. Debugging. Okay, so over here we have given our command line arguments. So whenever we run this particular application in debugger mode, so these command line arguments would be automatically given to the application, and we are using inlet trains.inp. So I will open that particular model in swim. So this particular model has multiple model objects or model elements. So if I click on conduits, we have like a couple of conduits: street 1, 2, 3, 4, 5, C 3, C 4, C 5, C 6, and so on. If we look at the hydrology part, I guess there should be a couple of subcatchments. We have S1, S2, S3 till S7. So these are all model elements. And basically, when you open a INP file, C creates certain objects, and those objects will have all the data for the relevant uh, model element. So for example, C will create a subcatchment object, and that object will have all these properties. Okay, so let's see in the source code where they have defined subcatchment. Okay, yeah. Okay, so this is struct sub area. Okay, an array of three sub areas. Okay, so this is sub area. So this is a subcatchment object. We here they have defined all the properties of subcatchment object. So if I open swim model, and if I look at this, so all the properties which you see over here are defined in this part of the source code. So ID is usually subcatchment name. Over here we have a comment which says what it actually represents. So ID is name. Okay, and RPT flag, I don't know what it represents, but yeah. Uh, we have gauge, out node, outlet node. This should be this one. Okay. Infiltration model, I think this should be there somewhere over here. Okay, infiltration data. So this is infiltration model, Horton. Uh, Infiltration object index. So this particular model, if you're defining it, you need to create another infiltration object as well, and it will be stored inside a infiltration array. And basically this particular uh, integer will give the index of that particular element from the infiltration array, and then it will give us this particular value, all these values. So this is sub area. Do we have it over here? I can't find it, but yeah. And I think all these parameters are from the simulation. So once you run the simulation, I guess this should be populated once you complete a simulation. Until then, they will be left blank. You can do this for all other objects as well. So for example, if you want to find how conduits are defined, you can do this as well. Conduit, and yep. Now you have conduit object, length, roughness, parallel. We have node object as well. Okay, so this is a T node object, and yep, node ID and node type code. So these are objects, and you can just go through it, and you will find all the objects or model elements which you can manually create inside Swim application or Swim GUI, and those can similarly be created using C um, code as well. And create them, you need to have an understanding of this particular file. So in the later part of this tutorial, we will be creating some objects as well. But yes, so these are objects. Now let's back to globals. So when you open a SWMM file, all these variables are initialized, and at the beginning, I think this is all about files and okay, all the external files which will be used by program and period. I think this is related to simulation time step, and okay, these are RPT flags are reporting options, and the data type will be of data structure ERPT flags. And the most interesting part is in this particular section, which is the arrays of various model elements. So the most interesting part is yeah, the links array or the subcatchments array or links array. Sorry, links I just told, yeah, nodes array. So these arrays will store all the nodes from your model. So for example, if I open this particular model using the source code, it will store all the these subcatchment objects inside the catch array, and it will store all the nodes into the nodes array. Where is it? This one. Similarly for links and conduits, okay, we have conduits array. So all the nodes which are created will be stored in these arrays. Now we will go into debug mode and we will inspect all these arrays, and we will have a quick look at them to understand how objects are created in C and how they are stored inside the C source code. So what I'll do is I'll just put the debugger point over here, and okay, this will start the application, and I will minimize the application. If I go to the locals window, I cannot see the global variables, even though I said like they are accessible throughout the life cycle of the application. But you still cannot see them in the locals window. The reason is locals window will only show you the local variables. A local variables are variables which exist in the current scope. So for example, our current scope is this two curly brackets. So all the variables which exist within these curly brackets will be shown inside the locals tab. And we have five variables over here. One is argc, so which will tell us the number count of the total arguments given. And then we have argv, it will give us the input arguments given to the application. So if I just copy it and go to the intermediate window, and if I just do Control V, press enter, I will get all the arguments which have been given. If I do arg0, it will give me first argument. If I do arg1, it will give me first argument. Similarly, if I do arg2, it will give me third argument. I can keep on doing this. Okay. So this is intermediate window where you can play around with the local variables and even with the global variables. But yeah, global variables are not visible over here. So for that, we have watch window over here. Okay, so I'll just clear everything here all. And what I will do is I will go to globals and I want to look at links inside my model. and I will go to watch window and I will just add the item to watch window. In case you are not able to see this watch window, what you can do is you can go to the debug options, and in debug go to windows, and over here we have watch. Okay, you can select watch. If you are unable to see the locals window, you can click on the locals as well, so it will display the locals window. If I just click on it, it will open the locals window and the watch window. So we have added link to the watch window, but this showing identifier link is undefined because we haven't yet initialized global variables. So what I will do is I will just click on step into, and we will now step into the run swim function. So we will dig deep into the swim run function. So now you can see our current scope is these two curly brackets. Okay, it starts at line. Sorry. Okay, yeah. Our current scope is these two curly brackets, which starts at line 194 and it ends at 252, I guess. Yes. Therefore, if we look at, okay, so I've stopped debugger by mistake. So what I will do is let's start again. I will, instead of stepping over, I will step into the function. And you can see now our local variables have changed because our current scope has changed. Our current scope is, uh, oh shit, now we have stepped into, yeah, this particular line. Okay, I will restart it. Yes. So now you can see the link variable is still a null variable, but it has been initialized. Okay, because we are into the run swim function. And if I click on next, so now these variables are initialized, but we don't have any value to them. If I step over, and the moment I step over from 207, what this particular function will do is it will open the swim model. It will parse the inp file, and it will read all the lines from that text file, and it will initialize all the variables which are required to represent the model elements from the inp file. So if I step over, the moment I step over, you could see this array would get populated. Okay, yes. So this is where it initializes all the model elements, and now if you see, we have certain values. So the first link is street 1. If I open the model, and if I look at the conduits, I can see there is something called a street 1 as well. I can do this for other global variables as well. If I go to, let's say, nodes, if I add it over here in the watch window, I can see all the nodes as well. But there is one issue over here. You can see it only displays one node at a time, and it doesn't displays other nodes which are there in the model. Same for the links. For this thing, what we can do is we can tell debugger that a links is an array, and it has, let's say, 10 uh, elements. And if I hit enter, it will show me a list of 10 elements from that particular array. Okay, and now I can see, the name of the first link is street, second is street 2, third is street 3, and so on. So till C7, and I can see, yeah, it has, you know, full of, it has similar links and conduits inside the model as well. So what I will do is, I think couple of links are still missing. So I will write instead of 10, I will write 20. Now it will have a list of 20 elements. Now, yeah. So we have most of the elements. I think we are still missing a couple of elements. So what I can do is I can just write a conservative number, link, comma, I will write 100. It will create an array of 100 elements. And you can see that after 16th element, we cannot see anything uh, in the debugger because we only have 16 elements. Okay, so the rest of the elements are just null values or we have some error because there is garbage data in our memory on those locations because there doesn't exist anything. Okay. So I'll just write link, comma, 16. Similarly, for nodes, you can do same thing. I can write 20. And if I see I have 20 elements inside this array, and I can inspect all of those elements. So for example, aux1, if I look at this particular element, it is aux1 plus type 0, invert elevation 974975, full depth. Um, yeah. So we have J10, J11. We can do same thing for subcatchments as well. I can do copy the name, paste it, comma, write 20. It will have list of 20 subcatchments. If I open it, we have certain values. We can compare them with our model as well. Most probably will have similar values. So this is how you inspect um, global variables using watch window, and object has all the objects which are required to define all the model elements from SWMM5. Next thing is we will create our own objects, okay, in main.c file. I'll just delete this thing and I'll remove the arguments as well. We can delete this because this main.c file is creating our application, which is this exe file and this .pdb file, and the actual source code or the simulation engine is in these files. So it doesn't matter what we write in this particular file, we are not altering any part of the swim engine. So I will now write certain lines of code, create a node object. Okay. So node is defined by T node, and I will create couple of nodes. Okay, node 1 and node 2 and node 3. Okay, so this is how we create node objects, but we haven't initialized them. And to initialize them, what we can do is we can write node 1 dot id. Uh, right, node id is 1, node id of node 2 is 2, node 3 has id node 3, and node 1 has invert level mm, of 100. Then node 2 has 200, node 3 has 300. Again, full depth, let's say 10, 20, and 30. Apart from that, we can add a couple of other parameters. Okay. No, let's not go with the new depth. Let's add search depth equal to 1, 2, 3. Yes. So now what we'll do is we'll add a debugger breakpoint and we'll run the application. And we'll go to the locals window and you can see we have initialized three variables. What I will do is I will just add debugger over here instead of this line. I'll just create application. Yes. Nope, it isn't accepting a debugger over here, but yeah. In this line, we have created three variables, but we haven't initialized it. And over here, you could see all the values are null values. If I step over it, you would see it has initialized node 1 with ID node 1. Same would be the case for other variables. If I step over, it has initialized all the three variables. And uh, add invert, add full depth. So it has added full depth as 10. You can step over, we'll do similar for other parameters. So search depth, let's see where is search depth. Over here it is added as well. If we go to node 3 and if we go to the search depth, we would see some garbage value. The moment I step over from this particular line, it will assign value 3 to search depth. Okay, it is assigned value 3. So this is how we create objects from SWMM5 source code. You can literally create any object which a user can create using user interface. Just you have to refer to the objects.h file, and this is how you initialize it, not initialize, declare it, and then initialize it. Next thing is global variables. So global variables are basically arrays, and throughout the program you create certain nodes and you just push those nodes or add those nodes into the global arrays. So what we will do is we will create a global array called as node. Okay, so nodes array. We will call it as nodes array. To do that, you need to write the name of the data type which you will be adding to the array. So keynotes and then a star to represent that array will only consist of the memory addresses. So star represents pointer. Pointers are basically memory addresses. So we are saying we want to create an array called as nodes array, and it will have, let's say, 20 elements, but we will be just be adding 3 elements. Okay, and we'll add a semicolon. So we will create a array called as nodes array, and it will have memory addresses of object type p nodes or struct type p node. And let's add those objects to uh, the array. Okay, so to do that, what we need to do is write nodes array, and its first element, which is at 0th index, will have memory address of node 1. Okay, so now you would see it is showing a red warning to us saying that there is some error. And to solve that, what we need to do is we need to assign a memory address instead of the object. Okay, so you need to add an and sign at the beginning. So if you add an and sign at the beginning of any variable, it will give you memory address of that particular variable. We will have a look at it as well. I will just restart the application and I'll step over. Now we have initialized this particular variable. We haven't added anything in this particular array. The moment I step over it, I can see first element has been assigned in the array. Okay, so this is node 1, first element, and the and person side. Okay, what is this? We can go to intermediate window. We'll just clear this, and if I type name of any variable, okay, node 1, it will give me the variable, and if I type and person before it, it will give me the memory address. Okay, so it returns this particular memory address, and I can even copy the memory address, and I can go to the debug option, and in debug I can go to memory, and in memory 1 it will give me this particular memory. What I can do is I can just copy and paste the memory address, and over here I have this thing. I can just go over here. Okay, yeah, so I can see there are a couple of values which we have assigned. So we have assigned 100 for node 1, and then we have 10, and then we have 1. So this is 10, this is 1. So we can actually see the memory address and the values which the memory stores in it. We can do this for a particular member as well. So node 1 dot, I can just click on search depth. It will give me a memory address of the search depth. I can copy this, I can paste it over here. You can see the memory address of the search tab and what value it has. So this is about objects and adding them to a nodes array. So what we are doing over here is, instead of adding the entire object, we are just adding the memory location of that object. And it's pretty efficient way of storing objects inside an array, because you're not storing the entire object. Instead, you're storing the memory address of that particular object. So I can do this for rest of the nodes as well. And I can add a debug point over here, remove this one. And if I step over it, I can see in the locals window, first and second array has been initialized. If I step over this line, it will also initialize the third, not array, but the element. So this was all about objects and global variables, and how arrays are used in global variables to store all the model elements from the SWMM model, which is defined in an INP file. Thank you for watching this video, and see you in the next video.